Good afternoon, everybody. My name's Kevin,
And I'm Andrew.
and we're here again. What is this, week 4, I guess? Week 5?
Week four, I think.
And this week we've been given the task to talk about our philosophy of teaching again. And what we had to do is find an article to either like supports our idea or supports our philosophy, or just like talks about teaching mathematics education, like K through 12, like why we do it.
Yeah. So the article I used to talk about my teaching philosophy, I kind of agree and disagree with, just in terms of just some of the ideas. But Professor Norton from Virginia Tech will really appreciate that I talk about this video, or talk about this article, because I'm talking about the constructivist approach to teaching by Ernst von Glaserfeld, and we actually read for class. And some of the main points that Ernst talked about was, I have written here that says, this learning theory has had unfortunate consequences. The usual learning theory has tended to focus attention on students' performance rather than on the reasons that prompt them to respond or act in a particular way. And that's one of the things I totally agree with. I feel like we stress to our students to be constantly successful, and we get very disappointed with them if they're not successful, and the fact that they don't perform on the tests that we give them. But Ernst, or von Glaserfeld, talks about how our goal needs to be more on the students' understanding of why they think, like why they come up with the wrong answer or why they come up with the right answer. And I think as a teacher, my teaching philosophy is going to be not to put pressure on students to be successful in terms of what we test as successful. I want my students to understand more than just perform well. Because what point is it if they just do it just to do well, but they don't understand the concepts behind it? Von Glaserfeld kind of just, I disagree with von Glaserfeld for the fact that he talks about the concept of viability and just saying how every answer is relative. There's a lot of different truths to a certain answer, and as a teaching philosophy, I don't really agree with that. I think math is kind of one method, or kind of just there's one answer to one problem. There's no relative answer, and he talked about that a lot. Just that, he says the introduction of the concept of viability, meaning relative answers, does away with the notion that there will be only one ultimate truth in this world. And I think that's one of the reasons that really drew me to math, is that in math there's truth. There's one answer to problems. There's no gray area with math. You either have the right answer or you don't have the right answer. And so this teaching philosophy I agree with mostly, but just this article is just very, very out there. Just the constructivist approach just talks about how we just need to be more socially reactive to students, and just to assume that every answer is not could be represented in a whole bunch of different ways.
I have a question.
Yeah.
You were talking about how your testing, we put a lot of stress on testing. So do you think that maybe when you're a teacher, your tests might not be as they might not be weighted as much, because you don't want the stress, you don't want to put pressure on them for testing. So maybe your tests might be more lax, I guess.
Yeah, since I also struggled with testing when I was in high school and everything, that's why I enjoy our classes now, because they're more homework based and understanding the homework more than tests. And I feel like our teachers in college have really realized that we want you to understand material rather than just perform well. And so as a teacher in high school, I think I'm just going to really encourage kids to really focus on the understanding of the methods that we talk about. A lot of practice problems, a lot of homework, a lot of, a lot of social interaction, like this article talks about, a lot of group understanding and group talking. Because I feel like if students teach students and students talk with students, they'll be more receptive to me, instructing them rather than hearing me talk all the time. So, but my teaching philosophy, I just really want this. I don't know, I'm still formulating it because I haven't really taught extensively yet. But for my tutoring experience and everything, I just really appreciate the fact that this article kind of presented some ideas that are important. Just putting more emphasis on understanding rather than testing, and the importance of social interaction and how key that is. And as a teacher, I want to incorporate those things into my teaching philosophy. But this article is very interesting, and I know Professor Norton will be very excited that I talked about it, because he talked up this article so much, but I think Kevin's going to talk a little bit more about his article.
My article was my article was called "Why Teach Mathematics," and it was a critical analysis on mathematics education by Peter Tilburg. And his first main two questions were, is math important for everyone, which the answer is yes. And then his second question is, what is the net gain of math knowledge that most people get from the K through 12 education? And he said the answer to that is a little. So there's a contradiction in saying that math is important for everybody, but then saying that most people only learn a little mathematics in their education. So he was kind of looking into like, why is that the case? And he talked about how like math competence opens doors to productive futures, and modern mathematics should be geared towards skills that are important to students' lives and their careers. And I think this has to do with a lot of like education reform ideals that talk about how education as a whole is built on getting you a job, like getting students jobs. Like when they graduate high school, the next thing you do, you go into the workforce, you build the economy, you build society. But I guess like I kind of agree with that and I kind of don't, because yes, education gets you a job, and like if you have a high school diploma, you have more chance of getting a job than somebody who doesn't. If you have a college degree, you have more chance of getting a job than somebody who doesn't. But I feel like education should be more than that. Like education should be about bettering yourself as a human being, like just opening your mind up to the knowledge of the world, kind of. And I think having an understanding of mathematics is something that helps you break down what the world is about, and it helps you like think logically. You have a beginning and you begin to formulate like your next step, and then your next step, like you have to have a foundation. And I think like having a mathematical mind is something that can get you into that mode of thinking. It can help you progress, I guess. So,
Yeah, I guess one thing I want to bring up is, you know how like you said, the stress is just trying to be successful, you know, financially, I guess, trying to get a job. Do you think as a teacher, do you think a lot of parents would freak out, or like the school would freak out if you were kind of stressing like, oh, I want education to be more than just getting a job? Like, you know, because I feel like our world puts a lot of pressure on like making kids successful, and that's determined by job.
No, yeah, it definitely does. I mean, the world puts a lot of stress on money.
Yeah.
Like, I mean, you look at social media today, like anything you see on TV pretty much just says, you know, you need money to be cool, you need money to have things, you need money to live. Obviously, you need money to pay bills and to have a roof over your head. So, I mean, getting a job is definitely important to survival, but I don't think it should be the only stress. You know what I'm saying?
Right. Yeah. I just feel like some parents and faculty would freak out if you're like,
no, yeah, I mean,
you're telling your kids just to like
not get a job. Not to, yeah, but I mean, I'm also telling them that they need to learn. So, but I think like overall, like knowledge can get you to the next step. It gets you to the next place that you need to be, and whether that next place is having a job or not, that's kind of up to you to decide. And being educated allows you to make that decision.
Yeah, I understand.
And there's another thing that was brought up in my article that it said we need to change the idea that mathematics is either you can do it or you can't, because obviously we've talked about how everybody can learn mathematics, so that's what we should try to do, is teach mathematics to everybody. And it says what should be avoided in math is an approach that continually revisits topics year after year without closure. And that really like hit me, because when I did my observation hours over at Giles High School, the Algebra 1 class and the Algebra 2 class were doing the exact same work week after week. And it just really like bothered me that these kids in the Algebra 2 class had the same Algebra 1 class the year before, but yet they're covering the same exact topics. So like what is being, that's what goes back to the net gain of mathematics. Like these students aren't really learning anything. They're just going through the motions of one class. They pass, or do they pass? I don't know. They just get sent to the next grade, and then they're going through the same thing. So what's really being learned? I don't know.
Yeah, that's crazy. Just
I
mean, even in high school, I remember everyone was really annoyed that the first month or 2 months of school was just review, and so we were like mentally checked out the first first quarter of school.
Yeah.
But
the problem is like I think like sometimes the students, they need that review because they still don't really understand it. Like that's what it says. It says year after year without closure. Like these students need to get a topic, learn it, and just grasp it and like make it themselves, like make it intrinsic almost.
Yeah, so I guess as teachers, it's Kevin's and my challenge to really make sure that we give closure on mathematical topics. Because I remember struggling in high school. Like our teachers showed us example problems, but I still don't understand the main concept, or I just don't. And so I feel like that's a big challenge to us. Also, like an exciting challenge is just how effective we can be as teachers if we really make sure that we give closure to every student. Even if that means meeting after school with a student to give him or her closure, or like maybe during like a study hall period, so there's no questions asked, or there's no, just I would just say there's no nervousness about understanding the concepts in the math class. Like I want all my students to be successful, and so I feel like if we are intentional, having closure in our mathematical teaching, students will really respond great to our methods and stuff like that.
Oh,
Yeah. So I mean, those were pretty much the articles we had to talk about.
Exciting news.
Yeah.
The girl, I don't know if you guys remember, the girl who was hiding her homework from us, she finally opened up and decided to do some mathematics. I think you helped her out a little bit.
Yeah. It hit me close to home. That, like I said, teaching is relational. It really is.
It really is.
And so now that this girl realizes that we're not creepers or we're not weird guys, she actually opened up and talked to us, and showed us what she was working on. And so I'm just excited about the possibility the rest of the semester of us actually helping her.
Yeah.
But
definitely works out. And we actually have there's a couple kids in the class who pretty much work on their mathematics every day we're there, and they actually come up to us and ask us for help as opposed to waiting for us to walk around. So that's pretty exciting.
Yeah.
And on top of that, this one kid, he was doing his SAT prep work, and this is a question that bothered Andrew and I. It was kind of ridiculous, but so the question asked, it was talking about a cube. So it said, what is the relation between the surface area of a cube and the volume of a cube? So I guess the first thing that you can say is that a cube, all the side lengths are the same, or edge lengths are the same. So for one side of a cube, you have, say it's x, then you have x times x, so that's x squared. Well, a cube, you think of a dice, it has 6 sides. So the surface area would be 6 times the x squared, but then the volume is x, is length times width times height, so it's x cubed. So how do you relate 6x squared to x cubed? And then it said the answer, he checked in the back of the SAT prep sheet, the answer was volume equals surface area to the the exponent 3 halves. And so you're saying that x cubed equals 6x squared to the 3 halves, which makes no sense to me at all.
And we checked again the answer in the back, and that's what answer in the back of the book, and that's what it said. So Kevin and I legitimately spent probably a good half an hour trying to give up all examples of this working, and we couldn't.
It was pretty ridiculous.
So it's kind of frustrating to see why that's the right answer.
That was upsetting. But any answers are more than appreciated.
But I think that concludes our week 4. And like I said, we're just gonna keep tutoring experiences and keep up our tutoring experiences and just still try to make our students successful. But I think that's it. So see you guys later.